Okay. Well, hello everyone. I'm Nemanja from Ethernal. Today I would like to present you our latest product named Blade. It is a blockchain that is built especially to target enterprise corporations. So let's get started with it. So in order for any piece of code to become a part of enterprise ecosystem, it needs to provide certain features. And now I will outline some of those features and later on elaborate how Blade meets all the conditions. So let's start with the first one. Of course, the top level of security is like the main thing. So any kind of data that is written to a storage, that is transferred to the communication line, or that is loaded into the memory must be completely saved. So protected in every situation. The second one is integration. If we introduce a new software within enterprise ecosystem, that software must not invade existing solution in any way. So the security of the existing solutions must stay the same and the proper operation of those systems must continue. Furthermore, all the employees within the corporation must have a friendly user interface so that they can send requests. The third one is reliability. So our blockchain has to work properly without fails, without breaking down, and the network must be alive 24/7. So the highest grade of resilience is required for these kinds of situations. And the last, not the least, is performance. There may be like thousands of employees inside of corporations, and all of them expect to receive responses promptly. Now we'll go through all of these requirements one by one and explain how Blade meets the requirements. So let's start with the security. How we did it? Well, Blade is secure by design, which means that during the period of architectural design, we need to identify all the possible threats that can appear, and then to mitigate them and have some recommendation how they can be solved. Later on, during the period of implementation, the implementation just should follow the recommendations, and that's it. And how we allocate those threats? Well, we use risk-based methodology. We employ like a bunch of threat models which will tell us where the threats are. This is one of the examples how a threat model looks like. You can see in the middle that there is a chain node, like a virtual machine that holds our software. And then there are a bunch of black lines that represent interaction between our node with the environment. On the other hand, there are red lines that represent trust boundaries. Every intersection between red line and the black line is a possible threat. So we need to address all of those if we want to have a secure software ready for any kind of enterprise ecosystem. I will now talk about the most important threats and how we mitigate them. So the first one is that data stored on disk can be disclosed. So we all know that blocks are stored in some kind of level DB or MDBX or any kind of database that is actually stationed on the disk of the virtual machine. In order to keep those data safe, we need to encrypt them. For those reasons, Blade employs keys to encrypt those data when they are written to the disk and then decrypt the data if they are loaded into the memory. The second threat deals with trafficking, so sending data through the communication lines. That data can be sniffed. Again, we need to protect data somehow, so encryption as well. We have two types of communication within the blockchain: peer-to-peer communication and RPC communication with the environment. In both cases, we utilize certificates. So for peer-to-peer communication, during the handshake, the nodes exchange certificates, and for the RPC communication, we utilize HTTPS, so certificates again. The third thread, which is quite interesting to me, is that some customers want to go one step even further. And they want that data which is loaded into the memory is encrypted as well, is protected. So how we deal with this? We actually ask our customers to allocate additional funds so that we can use trusted execution environments during the deployment of our solution. And the last, but not the least, is the unauthorized access to the keys that nodes use. Blade uses two types of private keys. The first one is BLS, and the second one elliptic curves. And both of those has to be protected and safe. For those reasons, obviously, we leverage key management systems, even hardware security models. That's it regarding security. Let's now move on to integration. As I said, when we include a new type of software into already existing environment, it shouldn't anyhow invade the operation of already existing software. For those purposes, we need to be fully compliant with the standard that is recommended by the Enterprise Corporation. The name of the standard is NIST Cybersecurity Framework. I will get in a minute about how this is integrated. So, even more, the integration itself needs to be straightforward. So, not many steps, so we do not burden the admins of those enterprises so that hate us and our software. They should be like the friend of us over there. And this is actually how that integration looks like. It isn't complicated as it looks in the picture. Like in the bottom right corner, you can see our blockchain, and all the other components around it are there to create some kind of integration system. So you can imagine this as our approach for account abstraction for enterprises. On the left, we have enterprise users. Those are actually employees that are going to use features of the blockchain. And what is the deal with them? They shouldn't be aware that they even use blockchain. They should log in with their usual credentials like email and password, and then send some requests to the system. They have a simple web application, and that application will send data to our system, which will be received by a transaction coordinator. The transaction coordinator is a component which is in charge for communication with the blockchain. So whenever a data is received to a transaction coordinator, a transaction is created from those data and submitted to blockchain. There is one really important thing in this integration part. Blockchain expects to receive data only from the transaction coordinator. Every other data should be disregarded. And for those purposes, transaction coordinator has a private key of its own. So every message sent to the blockchain is additionally signed with that private key. And then when the message is received by the blockchain, it can be verified against the public key of the transaction coordinator. If everything is okay, it will be included into the blockchain. Otherwise, it will be rejected. Now, let's move on to reliability. The first point, guys, I need some water. Just a second. Yeah, my mouth are completely dry. Okay, regarding reliability, the first thing that we need to have is a quality software. So what happens there? During the process of implementation, we need to follow all the possible continuous integration procedures. So nightly build, daily builds, automating testing, performance testing. If like performance somehow degrades, falls down, the complete process of development is stopped until we figure out what is going on, what piece of code made the performance test fail. So after we get the quality code, then we have a proper deployment. Our deployment is built in such a way that it can be configured for different users. Some users want like 5 validators, the other ones 10. The second one wants organization of blockchains, of load balancers in one way, the others in a second way, and so on and so on. When we configure that network, we only need one click to deploy the network and wait for a couple of minutes for network to be alive. Later on, we have one feature that I'm really proud of, and we call it self-recovery. So if any node fails during the regular lifetime of a blockchain, we have a self-recovery mechanism that will recover that node without any kind of interaction from the user manually. At the end, we track all the important metrics like health of consensus, block time, how blocks are populated, and so on, to figure out if we need any kind of additional intervention into the network. And how we do all of this deployment? Well, we have developed a tool for those purposes, and as you can see on the left, there is a menu which defines what can be configured. So we can configure number of validators, what will be computing power for each of the validators, number of full nodes, then load balancers, how will be load balancers connected to the full node, all the validators, then defined block explorers, some founds for initial accounts, and then smart contracts for Genesis. So the smart contracts each will be included in the first block. After clicking to deploy bug, you will get your network quite soon. Now let's move on to the performance, probably the most important part. First of all, I want to talk about EVM. We actually used, as it should be, official benchmark tests, and you can see the black lines. The blue lines. The blue lines is where we started a couple of months ago. The orange lines are where we were yesterday. During the night, I received the update of this diagram, but I haven't enough time to include it into the presentation. So at the moment, these red lines are still going down. And since this is like a process, I would like that they go down in the future significantly. Then let's talk a little bit about data layer, where we are going to store our blocks. We were considering two databases, LevelDB and MDBX, and considering performances and metrics of those databases and the features that they provide. And since we are targeting performances for our data layer, we decided to use LevelDB and then build a wrapper around it to add all the additional features that we require ourselves. For after we have finished that implementation, these are the numbers. For this consumption, if we want to save 10,000 fully completed blocks, fully populated blocks, we need less than 4 megabytes. If we want to read 100 blocks randomly, we'll need less than 16 seconds. These numbers are actually compared with some well-known blockchains, and I can tell you they are a couple of times better. Then the last and the most important performance is transactions per second, actually gas utilization per second. In this case, for our native token transfers, there are situations where we can reach 4,700 transactions per second. On average, we have 2,200. For ERC20 transfers, we can reach 3,300 per second, and on average, more than 1,600. ERC721, we have about 700 transactions per second. Now I want to spend a couple of minutes for additional features that we provide. the blockchain itself can be configured as layer 1 or layer 2. It has an integrated bridge if it is deployed as layer 2. Anyone configure its own stake and reward tokens, and of course we support governance. A regular account abstraction is on its way. It's being implemented as we speak. Now let's talk a little bit about the application of the blade. So, I'm not sure if you are familiar with Apex Fusion. It is a new environment, a new system that is being born as we speak, and it is intended to connect two worlds. Cardano UTX chains with DR chains. First of all, EVM chains. Later on, Cosmos chain will be introduced as well. And the thing is that there is something in the middle that provides exchange of tokens between those chains. If we simplify this picture, it will look like this. So Blade is in the middle, and Blade is like the highest level of security for exchanging tokens in this ecosystem. The other honorable mentions are these. Next gen blockchain is probably going to be built on top of Blade. It's going to use Blade technology. There is a Prometheus project that reads data from the blockchain and then sends it back. And Infinity Games, that project uses Blade to deploy smart contracts. There are some additional projects, but I cannot speak about them at this moment. We'll see what will happen. That's it, guys. I'm ready for questions.
Feel free to raise your hands if you do have a question.
No questions. Everything
That means good. Everything is
Everything
clear.
Yeah, I'm a great lecturer.
Give it up for Nemanja.